Did we get here?
Yeah, we're on the 12 for it.
Okay. So all we have left is this problem and one more. We just have 2 problems left, and then we are done with this note sheet, and we're done with our kind of lessons over factoring. So when we look at this here, factoring by grouping, we're going to group the terms up and take a greatest common factor out of each set of terms. And we do it in such a way that we have something in common with both of those terms and do it again. So for this here, we're going to look at the first 2 terms. 12n cubed plus 4n squared. We're going to group those together. And then we're going to group 3n plus 1 together. So the first thing I do, it doesn't matter which one we do, we can look at 12n cubed plus 4n squared, those 2 terms, and see if there's a greatest common factor. There's something in common with those 2 terms. And we're going to factor it out. Now the variable, we can look at it first. Well, n cubed and n squared has a greatest common factor of, well, n squared. We can take n squared out of both of those terms. Is there a greatest common factor between 12 and 4? Is there a number that divides into both 12 and 4? 2 does, but there's another. 4. 12 is divisible by 4, and well, 4 is also divisible by 4. So we can factor 4n squared out of both terms. If we factor 4 out of 12, 12 divided by 4 is 3. If we factor the n squared out of n cubed, we take 2 away from 3, we're left with 1. So 12n cubed divided by 4n squared leaves us with 3n. Now we can do the same thing with 4n squared. We can factor 4n squared out of 4n squared. Well, actually, we're just dividing it by itself, yes? Which is going to give us 1. Questions on this so far? So all we're doing is looking at those first 2 terms individually and finding the greatest common factor, something that's in common in both terms, and we divide it out. Now that we finished doing that, we're going to look at the other 2 terms. We're going to look for a greatest common factor between 3n and 1. 1. There is no other common factor between 3n and 1. So there's nothing we can take out, and we actually just bring it down. But even though there's not a greatest common factor between 3n and 1, our 2 terms that we do have something now in common with both, yes? So it's not always going to be the case that we have to factor something out of both terms, but the goal is to get whatever it is, we need something the same with both. In this case, we have 3n plus 1. Any questions on this here before we do the next step? Because our next step is just doing a similar step. We're now going to factor out that common term of 3n plus 1 out of both. We're going to divide it out. We're going to simplify it out of both terms. Because when we take 3n plus 1 out of our 4n squared times 3n plus 1, the only thing we have left is the 4n squared. Because we're dividing it out, we're removing the 3n plus 1 out of it. We're taking it and putting it in front. Just like we would a number. We can do the same thing with the 3n plus 1. Now the sign is still going to be plus, because the sign in front of our parentheses is plus. Yes. I can in a bit. It is also in Google Classroom. Now we are factoring 3n plus 1 out of 3n plus 1. We're dividing 3n plus 1 by itself. And whenever we divide something by itself, it simplifies to 1. We normally write the number in front of it, but the number in front of the parentheses is also just 1. So it tells us that when I factor 3n plus 1 out of both, we remove it from both terms, what is left over is our 4n squared plus 1. And we put what we factored out in front, telling us that this factors to 3n plus 1 times 4n squared plus 1. Now, as we look at both of these here, just to make sure we're completely factored, 3n and 1 does not have anything in common. The degree of this expression is 1, so that is as simplified as it gets. Now, 4n squared plus 1 does have a degree of 2, so there's a chance it could factor. However, 4 and 1 don't have any common factors. N squared plus 1, we don't have a sum of two squares, so even if it did, 4n squared and 1 are perfect squares, there's no way for us to factor that. So that tells us that 3n plus 1 times 4n squared plus 1 is completely factored. And that's it. That's all we have to do for this one here. Questions on any of this so far? Are you ready for the next one? And incidentally, the last one that we have. 244az plus 56ac minus 84yz minus 22yc. Up to this point, most of what we dealt with, the factors that we've had, have been nice, easy to work with. We can actually kind of look at them. These are a little big. Now, we haven't had to look for a greatest common factor amongst all four terms for any of the groupings that we've had up to this point. There might not be one here, but if there is, it might make these numbers easier to work with. Because if I'm able to take a factor out of all four, that means we're decreasing each of the numbers by that factor, which might give us some terms that are easier to work with. So we could look and see if 224, 56, 84, and 21 do have a common factor amongst all four. However, there could be a lot of numbers that we could have to check, because there could be a lot of things divisible by all four. However, I know whatever is going to divide into all four cannot be bigger than what? 21, yeah? Because if the number was, say, 24, well, we know for sure it's not going to divide by 21 nicely because, well, 21 over 24 won't divide nicely into a nice whole number. So the biggest number we could possibly have amongst all four has to be what? 21. That's the biggest factor we can have, yes? So 224 divided by 21. Not a factor. What I would do from there is, well, we know if it has to be a factor of all four, it still has to be a factor of 21. 21 has the least number, most likely the least number of possible factors. What other number is divisible by, or 21 divisible by? 7, yes? Might as well try it next. 224 divided by 7, yes? If this doesn't work, well, the next number we can try is what? 3. And that's it, because there's only 3 real possible factors that we can try. 224 divided by 732. That's a nice factor, yes? Our next number is what? I think it's 56. 56 divided by 7 is 8. Okay. 84 times divided by 7 is 12. And well, we know 21 is divisible by 7. So that means before we even start our factoring by grouping, it is possible to take a greatest common factor of 7 out. And if we do this, well, 224 divided by 7 is 32az. At this point here, I could we can all say for assuredly it's going to be nicer to work with factors of 32 or greatest common factors with 32 than 224, yes? Plus 56 divided by 7. If we factor 7 out of 56, we have 8ac. Minus, if we factor 7 out of 84, we divide it by 7, we get 12yz. Minus, we factor 7 out of 21, we get 3yc. Would I be incorrect in saying that these numbers are a lot nicer than what we started with? I mean, I would rather work with 32, 8, negative 12, negative 3 than 224, 56, negative 84, negative 21. This is the main reason we look for greatest common factors when factoring. That's why we look for it first. Because we take numbers that would make it a lot harder to work with to find the factors. It's still possible. It will still work, but the numbers are going to be a lot bigger. Makes sense? Because if we look at this here, especially if I look at my first two terms, because I'm always going to group the first two and last two together. First thing I'm looking for is a number, greatest common factor between 32 and 8. What number will go into 32 and 8? 8, yes? So that means I can factor 8 out of both numbers. Is there anything else in common with these two here? Hey. Here you go. Yes. So the other term that's in common is a. That's the only other thing in common with these two terms. So if we factor 8a out of 32a, 32 divided by 8 would give us 4. The a will factor out completely, leaving us with z. So if we factor 8a out of 32a, z, we get 4z. Now we're going to factor 8a out of 8ac. We're not factoring out a negative, it's still going to be positive. 8 divided by 8 is 1. A divided by our a is 1. And that just leaves us with c. Questions on this here? Interestingly enough, because we could still get there, 224 and 56. The greatest common factor between these two is 56. 224 divided by 56 is 4. So instead of having to divide 56a out of both terms by factoring out that 7, we're now factoring out 8. Does that kind of make sense? Well, what is 8 times 7? 56. So we still did it. It's just, it's lower, it's easier to work with. But that also means if we didn't factor it out at the start, we would have had to factor it out at the end. It's going to have to come out at some point. It's just where and when. If we do it first, it makes everything else nicer. Yes? Let's look at the last two terms. Negative 12yz minus 3yc. What's our common factor between 12 and 3? And y, 3 and y, yes? So I can factor 3y out of both terms, yes? So if I factor the 3y out of negative 12yz, negative 12 divided by 3 is what? 4, and it would be negative, yes? If I factor the y out of y, it factors completely, and I'm left with z, yes? But wait. that first term inside the parentheses, does it match the first term in our other one? No, it is the right number, but it's the wrong sign, yes? When we factor the 3y out of negative 3yc, it is also going to have the wrong sign, yes? So what could I do to actually fix that sign error? We could factor out a negative. Because if both of the signs are flipped, we can factor a negative out. Because if I'll factor out negative 3yz. Well, negative 12 divided by negative 3 is not negative anymore. It's now positive. We flip that sign and get them to match. Negative 3yc divided by negative 3. The negative and negative will make a positive. 3 over 3 is 1. Y over y is 1, leaving us with C. When we're factoring this out, if both signs are flipped, we got to factor a negative out to offset it, to fix that sign error, to get the signs to be the same inside that set of parentheses, so they're both the same. It feels like it should be more than just that to fix a sign error, but that's it. Now, it could be something as simple as if we had this here, well, our first term is negative, but it needs to be positive. Our second term is positive, it needs to be negative. Both signs are still flipped. So factoring a negative is going to turn that first term from negative to positive. And it's going to turn that second term from positive to negative. It will fix that sign error. Normally doesn't happen, but sometimes if we need to make them both negative and they're both positive, again, the signs are both flipped. We factor a negative out of a positive, it's going to become negative. But the big goal is making sure what's inside both of those parentheses are the same. That's the goal. Because now we can factor 4z plus c out of both terms. If I factor it out of the first, I'm going to be left with 8a. If I factor it out of the second, I'm going to be left with negative 3y. So it becomes 8a minus 3y. And it's been plus up to this point because the second term has been positive all the way up to this point. Since here it's negative, it's going to be minus. Questions on how we got to this here? What is it missing? The 7. Since we factored it out at the beginning, it still needs to be a part of our answer. And that's it. Questions on those here? Questions on any of this so far? And that really wraps up what I wanted to go back over, what I wanted to go over with factoring. These properties of factoring, how we go through factoring before we move on to the first chapter of the semester. However, we're not starting that next week. Monday, we don't have school. It's a built-in snow day. Tuesday is going to be a makeup day / review day. So then that's Tuesday. Wednesday, we'll go over the review. Thursday, Friday will be the test over factoring. I do a test over this factoring. 1, to make sure that we're good, we're still feeling good with factoring. And 2, it is a nice first grade in 200 points. Do well on this, and it's going to help you do well, especially throughout the rest of the year. It kind of does help build those points up. As we didn't have, especially have the syllabus grade, the 50 nice, easy 50 points, isn't in this semester. So it's a nice way to get some points. So that is it we're doing today. Monday or Tuesday will be the makeup day / review day. You'll get the review sheet, have time to work on it. I would make sure to be filling that out beyond just me just going through the review. So you have some more written on there. I would definitely have the formulas for all of them up there, and put your own notes, put it in your own words, steps, because otherwise it's literally just going to look like this. And if there's nothing else there to help you go from step to step, be it just questions or hints or whatever helps you remember, this is going to be nothing, especially looking at the test, because then you're going to try to decipher your own work as you're trying to take the test. You're going to spend you're going to waste more time trying to figure it out than you actually are solving. The review sheet should be a help, hint, not a crutch, to help you get there. Makes sense? All right. So one last worksheet.